All right, here we go. Find a volume of and fixed lateral surfaces, or fixed volumes and fixed lateral surfaces. So first off, let's review what I tried to teach you. What's 45 squared? I'll pause. The trick is, what's 1 more than 4? 5. What's 4 times 5? 20. And it ends in 25. So 45 times 45 is 2025. So try, what's 55 squared? What's 55 times 55? 1 more than 5 is 6. So and it ends in 25, so it's 3025. And it works with decimal points here. What's 3.5 squared? I'm pausing, just giving you a chance to do it. What's 1 more than 3? 4. 3 times 4 is 12. And since it's 3.5, it's going to be 12.25. And I'll pause and let you get the last one there. Maybe this first one you're going to get. It's okay. What's 8.5 times 8.5, or 8.5 squared? It would be 72.25. Eight times 9 is 72. Check on your calculator. Anyways, so here's the cat. Adrian is helping me out here. So number 3, you got the volume is 12. You got a fixed volume of 12, and you're going to have different lengths. And we're going to that you're starting with. So you have to find your different lengths or widths and heights, and what your surface areas are going to be. So if the length is 12, well, the width and height have to be 1 and 1. And so here I did it 12 by 1 by 1. The bottom and the top are going to be 2 times 12 times 1, so it's 24. The front and back are 12 times 1, so you multiply by 2 since there's 2 of them, just like this is 12 by 1, and you multiply by 2, 24. And then the right and left, it's 1 by 1, and you multiply that by 2. So anyways, that adds up to 50. So the surface area is 50. And when you have the numbers farther apart the numbers are, the bigger your surface area is going to be. And then, so if the length is 6, then the width is 2, and the height is 1. And so the front is 6 by 1, so you multiply by 2 to get the front and back. And then the top and bottom is 6 by 2, so you multiply that by 2 to get 24. And the right and left are 2 by 1, and you multiply that by 2 to get 4. And that adds up to 40 centimeters squared. And then if it's 4 by 3 by 1, the front is 4 by 1, so you multiply that by 2 to get 8. The top is 4 by 3, and you multiply that by 2 to get the top and bottom, so you get 24. And then the right is 3 by 1, so the right and left are 2 times 3 by 1. And 30 plus 8 is 38. So notice the numbers are getting smaller. As you get closer and closer to a cube, the numbers get smaller and smaller. Actually, the one that would give you the smallest surface area would be a ball, a sphere. But if it's like a polygon, it would be a square would give you the smallest surface area. Anyways, the front is 3 by 2. Multiply that by 2. The top and bottom is 3 by 2. You multiply that by 2. And the left side the right side is 2 by 2, and you multiply that by 2 to get the left and the right. You get 32. So centimeters squared. So there's number 3. Now number 4, this was surprising to me. I don't think I've ever done a problem like this. I don't know. But if the radius is 12 and the height is 4 of a, of a cylinder, so I drew the picture. Now the length by width of the rectangle, the width is like the height, and the length is the circumference of the circle, which is pi times diameter. So the lateral surface area is pi dh. Pi times diameter is the length, and height is the width of just the rectangle. So I just saved pi for last. 6 is your, if the radius is 3, the diameter is 6. I always put in the diameter and the radius. Diameter is the big one. And so you get 24 times pi, and I did the multiplying off to the side here, and get 75.36. I just rounded it to 75 centimeters squared. And then if we did a 12 by 1, which means the diameter is 2, you get pi dh again, which is 2 pi times 2 times 12, which is 24 pi again. And so you get the same answer. So I was like, let me try that again. So I just made up another one. What if it's, you get 12. What if it's the radius is 2 and the height is 6? So the diameter is 4. And it's just going to be 24 pi. So if the radius, you're going to get the same lateral surface area. Anyways, I thought that was kind of cool. Anyways, this time as it gets so this is going to have less volume because it's longer, and squeezed out is going to have less volume. Oh, volume, I forgot to do the volume on this one. Area of the base times height. The base is a circle, so pi r squared, pi times 9 squared, you get 9 pi. And so 9 pi times 4, it's 36 pi, and where did I do my work for that? Down here. So it's 113. There's centimeters cubed. That's the volume for that one. And on this one, I did the volume. I just plugged in for area of the base, pi r squared times height, pi times 1 squared times 12, which is just 12 pi. And then I did my work up here and got 37.68, which is 38 centimeters cubed. So the one that, for the same surface area, the one that gives you the most volume is, the one that's the fatter, shorter, fatter one will give you the best volume. But why do companies package like a cereal box where it's tall and skinny? You're gonna have to use a lot more cardboard, and you're getting less volume. And you ever thought about that? And the reason would be just because it looks bigger. The best way to package it, the cheapest way, would be to pack it in a cube. But that would just make it look smaller. So they package it tall and skinny, so it looks like you're getting more cereal. Anyways, there's lesson 12.4. End of chapter 12.